This is about the mean number of texts from section 7.3, extra examples. So suppose that we know the number of texts sent during a typical day by a randomly selected Homestead High School student follows a right skewed distribution. So the population here is right skewed. That's different. We don't see that very often, okay? And if you like this video, you can subscribe to the YouTube channel. With a mean of 15 and a standard deviation of 35, and it's right skewed. So we can still have a mean and standard deviation. So we're assuming the texting habits of students at Homestead are typical of those in the U.S. What's the likelihood a random sample of 50 high school students will send more than 1,000 texts? So we want to find the probability that X bar, okay, the average, one of the X bars is more than 20, which comes from taking 1,000 texts and dividing by 50 students. So we're looking for the probability that X bar is greater than 20, okay, in our sampling distribution of X bars. So the plan is that the problem is that our population distribution is not normal. So we wouldn't know what the area is, but we know what happens to the shape of the sampling distribution of X bars, because by the central limit theorem, which you may always abbreviate as CLT, the central limit theorem, since n, the sample size, is large, which specifically for the theorem means it's greater than 30. So 50 is greater than 30. The sampling distribution of X bars, or I'll just say the distribution of X bars is approximately, make sure you say the word approximately normal, otherwise it'll assume you mean exactly normal, so you have to say approximately normal. With the mean, mu sub x, what is the mean of the sampling distribution equal to? It's still the same as the population. Yep, 15. And the standard deviation of the sampling distribution is it the same or is it smaller? Is it the same as the population standard deviation of 35? No, it's smaller by the square root of the sample size. So whatever that is. So now we're ready to do our normal CDF. So this is our do. So we go normal CDF, and what's our lower bound? 20, because we want 20 and greater than. Our upper bound is infinity. We pop in our mean and we pop in our standard deviation, and we get 0.1562. So there is about a 16% chance. There is a 16% chance that a random sample of 50 students will have sent more than 1,000 texts.